In 3C here, we're gonna find and graph inverses of linear functions. And we will look at number 43 right here. Okay, so some notation to get familiar with first of all. So f of x is going to be your original function. Okay, so I'll put original. And then f inverse of x is the inverse function. Okay, and what you're going to do to find the inverse is you're going to switch x and y, and then solve, after you do that, solve for y in your new function. And we'll do that here on number 43. So it's written in functional notation, so I'm going to let that f of x be y. So really the original function is y equals 5x plus 1. So what I'm saying here is we switch x and y and solve for y. So I'm going to make this x, I'm going to make this y. So we just switch these two. Now we solve for y. So algebraically, get y alone. So I'm going to subtract 1. So 5y is equal to x minus 1. Now we're going to divide by 5. Divide both these by 5. So I get y equals 1/5 x minus 1/5. So that's the inverse, and I like to then write it as in functional notation. So f inverse of x is 1/5 x minus 1/5. And so now we're going to graph the inverse and the original. And also, all the functions are reflected over the line y equals x. So a function and its inverse are, when you look at inverses, are reflected over the line y equals x. Now, y equals x is y equals 1 over 1x plus 0. So that would basically be a line with a slope of 1, y-intercept of 0. So they're all reflected over the line y equals x, which cuts the first and the third quadrants right in half. And I would really like for you to draw that one on there as well. The directions don't say to, but draw your reflection line. And I start out doing this right away. So if I'm going to draw my reflection line on, I'll draw it in red. That's y equals 1 over 1x. So this is my y equals x reflection line. Okay, so there's what I'm going to label that y equals x. Okay, so now let's graph our original function. I'll do that in blue. So it's y equals 5x plus 1, so my y-intercept is 1. My slope is 5 over 1, so I'm going to rise 5, run 1. I'm going to actually go the other way too. I'm going to rise, go down 5, and run negative 1. Okay, so this would be, oops. And I'm not drawing this very straight, but there's my line. So that's f of x. I'll label that f of x. That's the original function. And now we have 1/5 x. This one right here. Our inverse function is 1/5 x minus 1/5. So it's at negative 1/5. So we're a little bit below the origin. And we're going to rise 1, run 5. So if I went up 1, right 5, I'd be right over here. If I went down 1, left 5, I'd be right just a little bit below negative 5, negative 1. And we draw that line. So there is f inverse of x. So I would like you to label them, and I would like you to draw the y equals x line on there as well. Okay, and notice if it is reflected, if we folded it there, they would match up on us. Then let's go to 61. State if the given functions are inverses. So what you want to do is, we want to just find the inverse of one of the functions. and see if they're inverses of each other. Let's actually do 62 here. Okay, so what I would do is just take one of them and find the inverse. Actually, let's do 61. So let's go, if this is y, I'm going to think of this first one as y equals negative 4x plus 20. Okay, so I'm going to change it to y and x. And so if I switched x and y, it'd be x equals negative 4y plus 20. So if I go down here and I start solving for x, I would minus 20, or start solving for y, excuse me. So x minus 20 equals negative 4y. I divide by negative 4, divide by negative 4, divide by negative 4. So I would get negative 1/4 x plus 5, negative over negative there, is equal to y. Excuse me. So if I look at the second function, okay, if I put my n back in, it'd be negative 1/4 n plus 5. If that is what the second function is, then they're inverses. Obviously, I have 2n minus 4 there, so these would be not inverses of each other. So it'd be no, or they are not inverses. So if you end up, take one function, it doesn't matter which function you start with. Just take one function, find the inverse, see if it's the other function.